Have you ever wondered how a company like Spotify just knows what new song you're going to love? Or how Netflix can handle viewing data from millions of people like every single day? Well, it's not magic, it's architecture. And today, we are pulling back the curtain on the exact blueprint for building these incredibly powerful data platforms on Microsoft Azure.
You know, it's so easy to get lost when you're starting out in data engineering. So many people chase after the newest, shiniest tool, or they try to memorize every single function in the library. But they're missing the most important thing, the big picture. It's kind of like trying to build a skyscraper by only studying how a hammer works. It just doesn't work.
And that really is the secret. The key to true mastery is to think with an architecture-first approach. It's all about understanding why a data lake is built a certain way, how a processing engine actually works under the hood, and what makes a data model genuinely useful for analysis. It's about becoming the architect, not just someone who knows how to use the tools. So in this explainer, we're going to walk through the 4 essential stages of this blueprint. We'll start with the storage foundation, then build up to the processing engine, add the modeling intelligence, and finally integrate the whole pipeline that brings it all together. And by the end, you're going to have this powerful mental model for building just about any data platform on Azure. Okay, let's dive right in. Stage 1, the foundation. Every great structure has to start with a solid, scalable, and super secure storage architecture. And in the world of Azure, this all begins with the data lake. So at the very bottom of our entire stack is Azure Data Lake Storage, or ADLS. The best way to think about it is as a massive, basically limitless repository that's built right on top of Azure Blob Storage. It's designed specifically to hold just enormous volumes of data in any format you can imagine. We're talking structured, semi-structured, totally raw files. This is where it all begins. Now, this is where you have to make a really critical architectural decision right at the very start. And it's all about this trade-off between how much you pay and how fast you can get your data. The hot tier, that gives you instant access to data you're using all the time, but it costs more. The archive tier, on the other hand, is incredibly cheap, perfect for long-term backups, but retrieving that data could take hours. Choosing the right tier here is absolutely fundamental to good design. And this slide really nails why we build on Azure Storage in the first place. Imagine you're running a global e-commerce site with millions of product images. You have to know those images are safe from a hard drive failing, secure from attacks, and always there for your customers. With features like automatic replication and encryption by default, Azure just handles all that complexity for you. So you can focus on building cool stuff, not just maintaining servers. All right, let's keep building. With all our data sitting comfortably in the lake, we now need an engine. We need a real powerhouse to process it, to clean it, and to transform all that raw data into something genuinely valuable. And that engine, my friends, is Apache Spark. Spark has become the de facto standard for big data processing. And honestly, it's for one simple reason: speed. Blazing speed. See, by doing its computations in memory across a whole cluster of machines, it completely avoids the slow process of constantly reading and writing to a disk. This lets it run up to 100 times faster than older systems. It's also a unified engine, which means it can handle everything from simple data cleanup to complex machine learning, all in one place. Now, to really get Spark, you have to understand its distributed architecture. Think of it like this. The driver program is the project manager, the brain of the whole operation. It breaks your big job down into smaller tasks. The cluster manager is like the HR department, allocating resources. And the executor nodes, they're the team members, the workers, each one processing a small chunk of the data in parallel. This is how Spark achieves that incredible speed and scale.
Okay, let's look under the hood for a sec. Spark uses these things called data abstractions. The original was the RDD, which is super resilient and flexible. But today, almost all modern Spark development uses data frames. And why is that? Well, because a data frame has a structured, table-like format, it lets Spark's Catalyst optimizer kick in. You can think of Catalyst as this little genius query planner that analyzes your code, figures out what you're trying to do, and then creates the most efficient execution plan possible. You trade a little bit of low-level control for a massive gain in performance. It's a no-brainer.
So we have the raw power to process petabytes of data with Spark. But all that power is pretty useless if the final output isn't structured for fast, intuitive analysis. This is where data processing meets data intelligence. We need to apply the time-tested principles of dimensional modeling to turn that processed data into real business wisdom. This quote from the pioneers who literally wrote the book on this stuff, it's not just a friendly suggestion, it's a foundational principle. The entire goal of our ETL process, extract, transform, load, is to deliver data into a clean, easy-to-query dimensional model. Period. And the crucial structure for that is the star schema. It sounds fancy, but it's beautifully simple. At the very center, you have a fact table. This contains the numbers, the measurements, things like sales amount or number of clicks. And then surrounding it, you have these dimension tables. They provide all the context, the who, what, where, and when. This simple structure is incredibly fast for business intelligence tools to query, and, just as important, for actual humans to understand.
But what happens when that context changes? A customer moves, a product gets a new name? This is a critical design choice you have to make. A type 1, slowly changing dimension is the simplest way. You just overwrite the old value. So if a customer moves from New York to LA, their record now just says LA. Simple, right? But you've lost the history. A type 2, however, preserves that history. We'd add a new row for that customer with the new address and use dates to show which record was active and when. Now, you can analyze sales to that customer both before and after their move. Powerful stuff.
So how do we actually pull off that powerful Type 2 history tracking? With something called surrogate keys. See, instead of using the customer ID from the original system, our ETL process assigns a brand new, unique, totally meaningless integer key to each version of that customer's record. This decouples our warehouse from the source systems and gives us the perfect mechanism to track history. It's an absolute, non-negotiable best practice. All right, we've laid the foundation, we've fired up the engine, and we've designed the intelligent structure. Now it's time to bring it all home. We're going to bring it all together into an integrated end-to-end pipeline using the Azure ecosystem. So this right here is the modern data flow on Azure. We use Azure Data Factory, or ADF, to orchestrate the whole show. It ingests the raw data into our data lake. Then ADF kicks off a job in Azure Databricks to run all our Spark code for the heavy lifting. And finally, that clean, modeled data gets loaded into Azure Synapse Analytics, where it's served up to business analysts and all their reporting tools. When you get inside ADF, it really is like building with Legos. Linked services are those special connectors that let you attach to all your different data sources, like a database or a web API. Datasets are the actual Lego bricks. They define the shape of your data. Pipelines? That's the instruction manual telling you how to connect the bricks together in the right order. And the integration runtime is the table you build it all on. It's the actual compute power that makes it all happen. And hey, if you're wondering if this is all just theory, well, look no further than the official Azure Data Engineer certification, the DP203. The exam's core domains, data storage, data processing, security, modeling, they map directly to the architectural blueprint we've just gone through. This just proves that understanding the architecture is exactly what they're testing for. So, if you take one thing away today, let it be this. Don't chase tools, master the blueprint. An architecture-first approach gives you that mental framework you need to solve any data problem, to choose the right tech for the job, and to build solutions that are robust and scalable. That right there is what separates a good data engineer from a truly great one. So, we've given you the structure, we've given you the principles. The blueprint is now yours. The only question left is, what are you going to build first?